Hello everyone, this is Hw10 and let's talk about homework 10. Question 1. From my lecture note, page 1 to 50 collects the definitions and simple properties of examples of stochastic process. The first one is Poisson process. Here, the Poisson process has the property is x0 equals to 0 and xt1 minus xt2 equal to the number of calls received in t2 in the period of t1, t2. And the probability of xt1 minus xt2 equals to k equals to this equation. And this is the graph. Its mean is lambda t, and the autocorrelation equals to lambda to the power of 2 times t1, t2 plus lambda times minimum of t1, t2. And the autocovariance equals to lambda times minus t1, t2. And the mean of Poisson process is lambda t, which is a linear function of t. It matches our common sense. The longer time we wait for the expected number of bus is larger. And second one is Poisson increment. And it is written in this form, which xt is a Poisson process. And the probability yt equals to n divided by sigma equals to this equation, and its mean equals to lambda. Its autocorrelation equals to lambda to the power of 2, 1. The absolute value of t1 minus t2 is greater than sigma, and when the absolute value of t1 minus t2 is less than sigma, the autocorrelation is lambda to the power t plus this equation. And here is the graph. This is lambda to the power of 2. This is lambda times plus lambda divided by sigma. And this area is lambda. It doesn't depend on sigma. And the covariance is this equation. And the third one is Poisson impulse, which is written in this form. And the graph is here. And the lambda t equals to the mean of Poisson impulse is lambda, and the autocorrelation equals to this one. And autocovariance equal to this one. And the fourth is semi-random telegraph signal, which we define in this. Xt equals to 1, 1k is even in the period of 0 to t, and it's minus 1, 1k is odd in the period of 0 to t. And the probability of xt equals to 1 equals this, and the probability of xt equals to minus 1 equals to this. And the mean of a semi-random telegraph signal is here. The autocorrelation is here, and autocovariance is Hw10 T2 minus Ext1 times Ext2, which is this equation. And here the random telegraph signal, we define the random variable alpha, which is the probability of alpha equal to 1 and equal to minus 1 equals to 1/2, and yt equals to alpha times xt. The lambda, the mean equals to 0, and autocorrelation is here, autovariance is here. And the 6 is random walk, which we can toss the fair coin. And we can write it in this equation. And the probability is equal to this one if the coin is fair. And lambda t equals the mean is equals to 0, and auto correlation is mean of n and m times s to the power 2, and covariance equals to this. And the last one is linear process, which we can write it into limit s equals to nearly to 0, t nearly equals to 0, and n goes to infinity, xt. And here is mean correlation, autocorrelation, and this is auto covariance.